The majority of this unit is going to be looking at concentrations of solutes dissolved in solutions. So we need to figure out what factors affect how much stuff, solute, can be dissolved in the solution. And so the word for that is solubility. And solubility is how much solid or solute can be dissolved in the total solution. The rest of this screencast is going to be looking at different ways that you can cause more solute to be dissolved or less, the variables that affect it. One way to change how much solid that you can dissolve is by changing the temperature. Typically, as you increase the temperature, more will dissolve. And so if you are looking to make really sweet tea, it would make more sense to add your sugar to hotter tea and allow it to cool than it would be to take the tea out of the refrigerator and try and add a whole bunch of sugar. You'll be able to get the sugar to dissolve more easily and more amount of it if it was in the warm tea. A second way to cause more to dissolve is by having a higher surface area. A higher surface area will get you more to dissolve. So in this image here, you see that you have a sugar cube versus granule sugar. And if you really wanted more to dissolve even after the granule sugar, you could use powdered sugar. You can see the grains in this spoon here. Each individual grain has lots of surface area. Or in the cube, you only have the surface area that is on the outside. The inside of this sugar will not dissolve until you've dissolved the outside. So it will take longer, and if you really want to get your substance to dissolve faster, you need to have a higher surface area. Another thing that affects the solubility of substances is pressure. Now, this is only for gases. Have you ever opened a soda? I'm sure you all have. And the noise that whenever you open a soda is a psh kind of sound. And what is really happening is when you open the soda, you are changing the pressure of the container. Because prior to opening the soda container, it's completely firm and has no give. It's under an extremely high pressure. And as soon as you break the container's seal, you are reducing the pressure, which allows carbon dioxide to come out of the soda. And as you can see in this image, you see the bubbles. And the bubbles were in the solution at a higher temperature. So having a higher temperature will cause more gas to be dissolved. So this affects your soda. In fact, if you make your soda warm, you often describe it as being flat. And what's really happening is all the bubbles have come out of the solution because the temperature is lower and less of the carbon dioxide can be dissolved in the solution at a lower temperature. This has another effect. The other application, which is a big deal, is the dissolved oxygen in lakes and ponds for fish. Fish breathe the oxygen from the water in through their gills, and that's what they live on. Now, typically, water will hold a certain amount of oxygen, and it's a different amount depending on the temperature. So what happens in bodies of water is when they get really warm, the amount of oxygen that they will hold goes way down, and you will sometimes see large amounts of fish dying, like in this image here. The picture that I took here is from the Inner Harbor in Baltimore, and at this particular time there was either an issue with the temperature of the water or the amount of algae in the water that was causing the amount of oxygen available to the fish to be reduced, causing them to die. One last set of terms for our factors affecting solubility. You have miscible and immiscible. And I'm showing you several images here of immiscible. Immiscible is where the solute and the solvent do not mix. So the two do not mix. They are immiscible. Miscible is when they mix. So in salad dressing, if you let it sit long enough, you will start to see the oil layer on the top and then the water layer or the vinegar layer on the bottom. And this is showing you immiscible. You can cause them to be mixed temporarily. And some solutions automatically mix on their own. But if you leave salad dressing sit long enough, it'll revert to its original two separated layers or immiscible layers. You can see in these other images there's a reaction going on where they shook it and caused it to get mixed, but as it sat for a longer time, it separated out. Some last factors that affect solubility are likes will dissolve likes. And what I mean by that is when you have a polar molecule trying to dissolve in a polar solvent, that will dissolve. And if you have nonpolars in other nonpolars, they will also dissolve. But if you try to mix a polar molecule in a nonpolar solvent, they will separate, they will not work. This example is the oil and the vinegar, because vinegar is polar and oil is nonpolar, and so they do not mix. Another thing that you can do is you can increase the number of carbons, which lowers the solubility, so less will be dissolved here. And if you increase the number of hydroxyl groups or alcohol, you will increase the solubility. So that's an opposite of the number of carbons. Solubility will also increase based on the stronger intermolecular forces. So the stronger the forces, the more like a polar molecule it is, and also with increased masses. So some factors that can change how well things will dissolve can also be attributed to the solute and the solvent and their interactions and what they're made of. Okay.